The last video we didn't finish problems 16 and 17 of topic 3, so let's go ahead and do that now. So 16 is find the perimeter and area of this rectangle. So for the perimeter of a rectangle, we know that's 2 lengths plus 2 widths. So this would be 2 times, the length is 4x squared y, plus 2 times the width, which is 13x. So the perimeter then would equal 8x squared y plus 26x. And that's our perimeter because they're unlike terms. We can't simplify any further. So for the area of a rectangle, it's length times width. So here we have the length is 4x squared y times the width, which is the height, which is, we'll say the width, which is 13x. So if we multiply those together, we see the area is 52x cubed y. Now looking at number 17, we have a trapezoid. They want the area of the trapezoid. So the formula for the area of a trapezoid is area is equal to 1/2 base 1 plus base 2 times the height. So the area would be equal to 0.5. Base 1 is 9a cubed b plus base 2 is 2a cubed b times the height, which is 6a squared. Now the first thing we're going to do is simplify the terms in the parentheses. So that's going to give me 11a cubed b times 6a squared. Now 6 times 11 is 66. Half of 66 is 33. So we have 33a to the, since we're multiplying here, is 3 plus 2a to the 5b. So that would be our area, 33a to the 5th b. Now topic 4, scientific notation. We can use our calculator to do this. So we're going to get our calculator. First thing we're going to do is go to mode, and we're going to change to scientific notation, and go back. Now, the first one, I'm going to put it in my calculator. 8.6 times 10 to the negative 4 plus 6.7 times 10 to the negative 5. Hit enter. I have 9.27 times 10 to the negative 4. Problem 19. We have 3.5 times 10 to the 3rd power minus 9 times 10 to the 1st power. It gives me 3.41 times 10 to the 3rd power. Problem 20. Look at problem 20. We have 5.6 times 10 to the 4th power times 4.5 times 10 to the 6th power. That's going to give us 2.52 times 10 to the 11th power. Looking at problem 21, we have 7.6 times 10 to the negative 7 power times 8.9 times 10 to the negative 2 power. And that gives us 6.764 times 10 to the negative 8 power. Looking at problem 22, we have 3.9 times 10 to the negative 12 power divided by, So we're doing division here. So let's back up and let's put parentheses here. Second, insert parentheses. And let's put a parenthesis here. Here. Okay, now we're dividing by, in parentheses, we're going to put 4 times 10 to the 4th power. Close parentheses. Hit enter. Okay, so we have 9.75 times 10 to the negative 17. Okay, we'll do problem 23. In parentheses, we'll put 1.75 times 10 to the 5th power. We'll close the parentheses. Divide. Open the parentheses again. 5 times 10 to the negative 3 power. Close the parentheses. Hit enter. So we have 3.5 times 10 to the 7th power. Okay. Now let's look at the word problem 24. It says the continent of North America has an area of approximately 9.4 times 10 to the 6 square miles. The area of Asia is approximately 1.74 times 10 to the 7th square miles. Approximately how many square miles larger is Asia than North America? So if that's our question, we're going to say we have 1.74 times 10 to the 7th square miles minus 9.4 times 10 to the 6th square miles. So if we put that in our calculator, 1.74 times 10 to the 7th power minus 9.4 times 10 to the 6th power, and we get 8 times 10 to the 6th. So it's 8 times 10 to the 6th square miles. That's how much larger Asia is than North America. All right, so that finishes that topic 4. Now let's look at topic 5. Topic 5 deals with graphing exponential functions. And we're going to graph each of these functions. So before I put this in my calculator, we want to do us a table. We're going to make this easy for ourselves. So let's do us a table. We have x and y values. The x values we want are negative 2, negative 1, 0, 1, and 2. Now before I put this in my calculator, I'm going to go back to mode. And I'm going to change to normal, my normal setting right there. You see that? I'm going to go to normal. Okay, now I'm going to go to y equals. I'm going to put in this equation that we have here, which is y equals 3 raised to the x power minus 4. Okay, we have that, and now we're going to go second table. So from this, now we're going to read off the data that we want. So at negative 2, we have negative 3 point, let's say negative 3.9. 3.9. At negative 1, we have 3.67, negative 3.67. At 0, we have negative 3. At 1, we have negative 1. And at 2, we have 5. Okay, so there are our data points. Now, let's graph these. So at negative 2, we have negative 1, 2, 3, 4. So it's negative 3.9. So it's right here. At negative 1, we have about 3.5. 3.7, close to 3.7. At 0, we have negative 3. At 1, we have negative 1. And at 2, we have 5. Okay, so our graph is going to look something like this. It's going to turn up. So it's going to be like this. So that's going to be our exponential curve, and if you notice here we have an asymptote. We have an asymptote here. Okay, so they ask us a number of questions here. One, since it's going up, as the x values are increasing, the y values are also increasing, so that's growth. The domain, you can see that it starts in the x direction at negative infinity, and here you can see where this is going to continue to go right forever, so it'll be all real values, all real numbers would be our domain. Our range, if you look at this, it looks like it's all numbers greater than -4. Starts here and goes up. So it's all numbers greater than, y greater than -4. The y-intercept, we can see right here when x is 0, the y-intercept is -3. So it's 0, -3. The asymptote is at y equals -4. This thing approaches 4 but never actually touches 4. So, okay, that's that one. Now let's look at the next one. So the next one will again do us a table. X, Y. And we'll do the values -2, -1, 0, 1, and 2. I'm going to take my calculator, go back to y equals, clear out the equation I had, and I'm going to put this equation in. Y is equal to, so a half is 0.5 times, in parentheses I have 1 divided by 4, and I'm going to raise that to the x power. So to fill out our table, let's go to second table. So for -2 we have 8. For -1 we have 2. For 0 we have 0.5. For 1 we have 0.125. And for 2 we have 0.031. Okay, so let's graph this. Now, if you notice, as my y values increase, as my x values increase, my y values are decreasing. So this is a decay function. Now let's graph it. So at -2 I have 8. Right here. And at -1 I have 2. Right here. At 0, I have 0.5 right here. At 1, I have 0.125. At 2, I have. So it's kind of easy to see that we're coming down like this. Coming down like this. So that's our exponential function. It's a decay function. It's going down. The domain, again, is from as far right as you can go to as far left as you can go, because this continues to spread out more and more and more all the way to negative infinity. So, again, the domain is all real numbers. Now, the range, the y values would be greater than 0. They wouldn't be equal to 0 because this thing never ever quite touches 0, or the x-axis. The y-intercept was where x was 0, so it's 0.5, so it's 0, 0.5. The asymptote is at y is equal to 0. That's that problem. Let's move to 27. Again, we're going to get us a table. So we have x, values, y values, -2, -1, 0, 1, 2. Take our calculator. Go back to y equals. Clear that function and let's put in y is equal to 3 divided by 2 times 2 raised to the x power plus 1. Now let's go to our table, second table. Okay, so at -2 we have 1.375, 1.375. At -1 we have 1.75, 1.75. At 0, 2.5. At 1 we have 4, and at 2 we have 7. Okay. Now, as our x is increasing, our y is decreasing. So this is going to be a growth function. We know that. Now let's plot it, see what it looks like. So at -2, it's 1.375. 1.375. There's 1.375. At -1, it's 1.75. There. At 0, it's 2.5. 2.5. At 1, it's 4. And at 2, it's 7. So we can see that the graph is going like this. Coming up like this. Okay, so again, the domain, all real numbers. The range would be y greater than 1. The y-intercept, the value where x is 0 is 2.5, so I have 0, 2.5. The asymptote is at y is equal to 1. Okay, so that's topics 4 and 5. In the next video, we'll cover the rest of the topics.